So I have taken two examples here. In the first example, two inputs A and B are present, and in this gate two inputs C and D are present. Fine. So what is happening? This is the NOR gate. It will give A plus B ka whole complement. This will give C plus D ka whole complement. Fine. Now this is an NAND gate. So what we will get? Y is equals to A plus B ka whole complement. Just a second. A plus B ka whole complement. Fine. And this is C plus D ka whole complement and whole complement of this. Fine. So now we will solve this expression and we will get this. So here I will be using De Morgan's theorem. So what is De Morgan's theorem? If this is present, so what we will get? We get A bar. We get A bar. We get A bar plus B bar. Okay. And if second theorem is if A plus B whole complement is present, what we will get? A bar dot B bar. Means what is happening in the De Morgan's theorem, that this bar is getting split into individual inputs and this sign is getting reversed. Fine. Here dot was present, so converted into plus. Here plus was present, so converted into dot. Fine. So then in the similar way we would solve this. Okay, so here what we will get? We will get A plus B one complement and another complement plus C plus D a complement and another complement. Fine. So what will be the final output? A plus B plus C plus D. This would be the final output of this whole example. Fine. Now let us come to this example. So what here we will get? We will get A dot B bar, and here we will get C dot D bar. Fine. So now these will be passed here. So what here we will get? Y is equals to A dot B ka bar and another input is C dot D ka bar. Now whole bar. Fine. Now when we will further solve, it will become A dot B ka complement converted into dot, C dot D ka complement. Fine. Now this would give this final expression. Y is equals to A dot B dot C dot D. Fine. So these were the two basic examples जिसमें कि हमने combination of NOR and NAND gate consider करा, NAND and NOR gate का combination हमने consider करा. ठीक है. So these were the examples based on the NAND and the NOR gate. Fine. Now let's move to the special purpose gates. So what I have told you earlier, the special purpose gates are XOR gate and the XNOR gate. Fine. So the this is the basic symbol of the XOR gate. This is the basic symbol of the XOR gate. This is the basic symbol of the XOR gate, OR gate, and one more line here. Fine. This is the basic symbol of the XOR gate. Fine. This is the basic symbol of the XOR gate. Here two inputs are present, A and B, and we are getting Y as the output. And this is the basic symbol to represent the XOR operation. Plus sign inside a circle. Fine. Plus sign inside a circle. Okay. And when this expression is expanded, we will get A bar B plus AB bar. So this is the expanded version of this A XOR B expression. Fine. Now this XOR gate is also known as inequality detector. Fine. So this XOR gate is also known as inequality detector. This, okay. So what this XOR gate will do? This XOR gate will basically give the output as 1 whenever it detects an inequality. Okay. So here two inputs were available. Fine. So based on the two inputs, we would get total 4 combinations. So 1, 2, 3, and 4. Okay. So total 4 combinations are present. So total 4 combinations are present here. Fine. Now total 4 combinations are present, and this is the inequality detector. So here both the inputs are 0 and both the inputs are 0, means both the inputs are equal, so it would give the output as 0. In the last case also, both the inputs are 1 and both the inputs are equal, so it will give 0 as our output. Fine. Now here in these two cases, one of the input is 0 and another is a 1. Here one is 0, one is here, this input is 1 and another is 0. Fine. So here what it is detecting? Inequality. Okay. So here it is giving the output as 1. As this is the inequality detector, so it will give the output as 1 whenever it detects the inequality in the input. Fine. So this is the basic of the XOR gate. Fine. Now coming to the next thing, likewise I had told you in the NAND gate, 3 input NAND gate and all. So XOR gate is also known as odd number of ones detector. Right? XOR gate is also known as odd number of ones detector. Here you can see in the previous slide also, in the previous thing also, what is happening here? Only one number of one were 1, so it is giving the output as 1. Here only one single 1 was present, so output was 1. Fine. Now coming to this slide, so here XOR gate is also known as odd number of ones detector. Fine. So let us take an example of 3 input XOR gate. Fine. So total 8 combinations are present. Okay. And for the better understanding, I have made a column here where number of ones are written, means in these combinations how many number of ones are present, it is written here. In the first case, number of ones are 0 as no 0 is present, so this is the even scenario. Now here this is the single 1, so number of ones 1, and this is odd number, so we are getting the output as 1 because it is odd number of ones detector. Now here only one single 1 is present, it is also odd, so output is 1. Now here 1 and 2 ones are present. Okay, so output would be 0 because 2 is an even number. Now here only single 1, so single 1 is odd, so we are getting the output as 1. Here two ones are present, 2 is an even number, so we are getting the output as 0. Here also 2 ones are present, 2 is an even number, so we are getting the output as 0. Here 3 ones are present, 3 is an odd number, so we are getting the output as 1 because this is basically a odd number of ones detector. Now coming to the XNOR gate. Okay, so XNOR gate, the basic symbol of the XNOR gate is XOR gate and a dot here. Fine. This is the basic symbol of the XNOR gate. Fine. This is the basic symbol of the XNOR gate. This is also present over here. Here two inputs are present, A and B, and we are getting the output Y. Fine. Now for representing the XNOR operation, for the XNOR operation, this symbol is used, a dot within a circle. This symbol is used. Fine. So the expression would be Y is equals to A XNOR B or B plus A bar B bar. Fine. This is the basic functionality of the basic expression of the XNOR gate. Okay. So this is the basic truth table of the XNOR gate. Okay. Now this XNOR gate is also known as the equality detector. So what it will do, this gate is also known as the inequality detector. So what it will do, whenever it will see both the inputs are equal. Okay, here two inputs are equal 0 0, here two inputs are equal 1 and 1, so it will give the output as 1, and when both the inputs are not equal, it will give the output as 0. Right? So this gate is known as equality detector and XOR gate was known as inequality detector. Fine. So this is the basic working of the XNOR gate. Now let us take some more examples. Now what I have done here, I have taken XNOR gate for odd number of inputs. Fine. So if in the XNOR gate, basically it depends on the number of inputs also. In XNOR gate, if the number of inputs is odd, just a second. In XNOR gate, if the number of inputs are odd, it will act as odd number of ones detector. Fine. Here you can see. Now here the three inputs A, B and C are taken. Okay. These are all the possible combinations of the three inputs. Fine. Total 8 combinations. Now this column shows the number of ones present. here in this first case no one is present, 0 1, so this is an even number, fine, so it will give the output as 0. Here in this case single one, here also in this case single one, so in both the cases it will give the output as 1. Here two ones are present, okay, so it will give the output as 0 because it is odd number of ones detector. Now here in this case only single one is present, so it will give output as 1 as number of ones are odd. Now here in this case, here and here two ones are present, 2 is an even number, so we will get 0 as our output. Fine. Here in this case also 2 ones are present, so we will get 0 as our output because this is an odd number of ones detector. Fine. Now 1 2 and 3 three number of ones are present and 3 is an odd number, so we will get 1 as our output. Fine. And now coming to the even number of inputs, here 4 inputs are taken into consideration, A, B, C and D. Now for 4 inputs, 2 to the power 4, that is equal to total 16 combinations. Total 16 combinations are present. Okay, so here total 16 combinations are present from here to here. Fine. Total 16 combinations are present. Okay. Now you can see that what is happening here, if inputs are even number, means for even number of inputs it acts as a even number of input detector. Fine. For the odd number of input it was acting as a odd number of ones detector, and for even number of inputs it will act as even number of ones detector. Sorry, means यहाँ पे जो है odd number of inputs पे it will act as odd number of ones detector, and for even number of inputs it will act as even number of ones detector. Fine. So what is happening here? Okay, so let me write down. For odd number of inputs it will act as odd number of ones detector, and for even number of inputs it will act as even number of ones detector. Fine. So this is the basic thing. Okay, now here in this case you can see in the first scenario there are no number of ones present, so this column basically represents the number of ones. So here in this case no one, here in the first scenario no one is present, so 0 is an even number, so it will give 1 as the output. Now here single one, so output will be 0. Here single one, so output would be 0. Now here two ones are present, so 2 is an even number, so we will get 1 as our output. Here single one means odd number of 1, so output would be 0, because here what is it is doing, it is even number of ones detector. Even number of ones detector, it means whenever in whole table you can check wherever there are even number of ones present. Okay, so it is giving the output as 1. Fine. So I hope that you might have understood what are the basic functionality of the XOR gate. Fine. So for the XNOR gate, if the number of inputs are odd, it would act as odd number of ones detector, है ना. यहाँ पे अगर odd number of मतलब inputs होंगे तो हमारा odd number of ones detector की तरह काम करेगा. यहाँ पे अगर even number of inputs होंगे तो हमारा even number of ones detector की तरह काम करेगा. Okay. Now coming to the conclusions of the XOR or the XOR gate. Just a second. Now coming to the conclusions for the XOR and the XNOR gate. Fine. In the XOR gate, it is odd number of ones detector. It does not depend on the number of the inputs. Fine. Let us take an example. What was the symbol of the XOR gate? Symbol of the XOR gate was this. Fine. So this. Okay, just a second. Okay, so what is happening here? Here 1 2 3 4 5 inputs are present, so basically it does not depend on the number of inputs present. Okay, so here how many number of ones are there? So here how many number of ones are here? Number of ones कितने हैं यहाँ पे? तो 1 2 एंड 3। नंबर ऑफ वंस 3 है। इसका जो फाइनल आउटपुट आएगा वो हमारा क्या आ जाएगा, इसका जो फाइनल आउटपुट आएगा वो हमारा क्या आ जाएगा, वो आ जाएगा 1। इसका फाइनल आउटपुट आ जाएगा हमारा 1। सो वी विल बी गेटिंग फाइनल आउटपुट हियर एज 1 बिकॉज number of ones present are number of ones present are 3 and this is an odd number. So in case of the XOR gate we would get the output as 1 here. Fine. Now in case of the XNOR gate, what is happening? In case of the XNOR gate, if even number of inputs are present, it acts as an even number of ones detector, and in this case XNOR is equals to XOR का complement. Fine. And if odd number of inputs are present, it would act as a odd number of ones detector. Fine. So let me explain you this with the example. Fine. Example for the XNOR gate. Okay. 1 1 0 1 2 3 4 inputs. Fine. And let us take 5 inputs 1 2 3 4 5 and 6 inputs. Fine. So here what is happening, 1 2 3 4 5 and 6 नंबर ऑफ इनपुट्स हमारे पास कितने हैं, नंबर ऑफ इनपुट्स हैं हमारे पास, नंबर ऑफ इनपुट्स हमारे पास कितने हैं, 6। ठीक है, नंबर ऑफ इनपुट्स हैं 6। ठीक है, सो फॉर इवन नंबर ऑफ इनपुट्स इट एक्ट्स एज इवन नंबर ऑफ वंस डिटेक्टर। ठीक है, तो नंबर ऑफ वंस कितने हैं हमारे पास, नंबर ऑफ वंस कितने हैं इस इनपुट में हमारे पास, नंबर ऑफ वंस कितने हैं, तो 1 2 3 4। फाइन, नंबर ऑफ वंस कितने हैं 4। तो इसका जो फाइनल आउटपुट क्या आ जाएगा, क्योंकि नंबर ऑफ वंस हमारे पास कितने हैं 4, ये भी हमारे पास इवन है। ठीक है, तो इसका फाइनल आउटपुट क्या आ जाएगा, इसका फाइनल आउटपुट आ जाएगा 1। फाइन, so this is the for XNOR gate. Fine. Now I am just making some changes. So 1 2 3 4 1 2 3 4 5. Okay, so now let us make number of inputs 5. Okay, so in this case number of inputs is, in this case number of inputs are 5. Okay, 1 2 3 4 5 inputs. Okay, so for odd number of inputs it acts as odd number of ones detector, and number of ones are there 1 2 3 and 4. So this is even number. Okay, now what will what output it will give, it will give the output as 0. Why? Because here the number of ones are even and it inputs were 5. So inputs were 5, so it would act as the odd number of ones detector, but here we are getting even number of ones, so we will get the output as 0. Fine. Similarly in the other case means you can cross check by taking the some examples on your own also. Now as I have told you, for even number of ones detector XNOR is equals to XOR का complement, and for odd number of ones detector XOR is equals to XNOR. Fine. So in this case what is happening, here two inputs are present. Okay, even number of inputs, so XNOR is equals to XOR का complement. This thing is applied here. Here also 1 2 3 4 inputs are present, even number of inputs are there, so what happened, XNOR का complement. Fine. And here fine, 1 2 3 1 2 3 4 5 inputs are present, so XOR is equals to XNOR. For the odd number of inputs XOR is equals to XNOR. Fine, you can see for the 5 number of for the odd number of inputs, this scenario means this case and last case. Okay, so XOR is equals to XNOR for odd number of inputs. Fine. Now coming to the some facts about XOR and XNOR. Fine. Now coming to some facts of XNOR and XNOR. XOR and XNOR. So this is XOR. Okay, now what is happening here, on one of the input I have given 1 and on the another A is applied. Fine. If A is 1, not in the first scenario A is 1, so 1 XORed with 0 means this one XORed with this 0. What is the output we are getting? We are getting the output as 1. Fine. Okay, because XOR is a inequality detector, so here inequality was present, so we are getting the output as 1. Now in the next scenario 1 is here. Okay, so this is for A is equals to 1 and this is the one input that we have applied. Now here both the inputs are 1, so it XOR is basically the inequality detector. Okay, but here equal things are present, so output would be 0. Fine. So we can say in XOR gate, if any of the input is 1, अगर कोई भी input हमारा 1 होगा, so other output is complemented. This you can understand it easily here. A is 0 and 1 and the other input is 1 and 1. So in this case, what is the output? Output is 1, and in this case the output is 0. So whatever A is present, it is means Y is equals to A ka complement. Right? Y is equals to A ka complement. Fine. Y is equals to A ka complement. Okay. So this is the basic point that is explained here. In XOR gate, if any of the input is 1, the other input is complemented. Fine. Now let us coming to the XNOR gate. So here in the XNOR gate, what is happening? Similarly, we have taken one of the input as 0. So we can make the truth table A, 0 and 1, and here 0, 0. Fine. So this is basically the equality detector. So when both the inputs are 0, so we will getting the output as 1. Both the inputs are not 0, then we will getting the output as 0. So what is happening here also? That Y is the complement of A. Y, what we are getting is the complement of this thing. Okay. So in XNOR gate, if any of the input is 0, the other input is complemented, or we can say in the output we get the complement of A. Fine. So these were the two scenarios that I have told you. Okay. So these were the two scenarios. Fine. So this you should remember. I hope till now you must have understood everything. Fine. Now next, coming to the some reminders or some important points that you should keep in mind. Okay. So first is for the XOR gate. Fine. In XOR gate, when XOR gate is what? XOR gate is a inequality detector. Fine. So when A is XORed with A complement, it is giving 1. Fine. You can see that if we are taking if we are taking A here, A complement here. Fine. So what is happening? 0, 1. So complement will be 1, 0. Fine. It is what? It is an inequality detector. So in both the case, it will give the output as 1. So this is the basic of this thing. Fine. This I have told you with the help of this truth table. Fine. Now you can keep some points in mind that when A is when A is XORed with 1, we get A complement. When A is XORed with 0, we get A. When A is XORed with A, we get 0. And when A is XORed with A complement, we get 1 as our output. Fine. Similarly, in the XNOR gate, when A is XNORed with 1, we get 1. Okay. Oh, sorry, we get A. Here we are getting A. Fine. When A is XNORed with 1, we are getting A as the output. When A is XNORed with 0, we are getting A complement as the output. When A is XNORed with A, fine, we are getting 1. In this case, cause it is the equality detector. Fine. And when A is XORed with A complement, then we are getting 0 as our output. Fine. Now, let's come to one question. Okay. So this is basically the question. Okay. So what is happening in this question? This is the basic question. That this is the left hand side, and you have to prove this left hand side is equal to this expression. Fine. So what we have taken? First we have taken left hand side, we have written this. We have written 1 XORed with P XOR Q. This whole thing we have written. Now what we have done in the another step, we have done the pairing. 1 XORed with P, one pair, this another pair, this another pair, this another pair. Fine. Okay. So now 1 XORed with P, simple. Now here what is happening? We can say, no, we can see that P XOR Q, this we can take as, if we can assume this as, for example, say X. Fine. So this is also X. Fine. Now what is happening in this whole thing till here? What is happening? It is happening that X is XORed with X. Okay. So when two same inputs are XORed, what is the output? The output is 0. Fine. And when 1 is XORed with P, we get P complement here. These two are the same inputs or the equal inputs. So we are getting 0. Now Q XORed with 0, we would get Q. Fine. Now what we have done the pairing of this. So Q XORed with 0 XORed with Q. What we will get? We will get Q here. Okay. So this is the normal thing of P X, means this remains here only P bar P complement, and the output of this is Q. So this is the final left hand side. Okay. Now when we would solve this further, we would get this thing. Okay. So now how we will solve, I will explain you that what was the basic of this. It was A complement B plus AB complement, right? So what we have got P complement XORed with Q. Fine. So P complement XORed with Q. So what we will get? We will get P complement का complement into Q plus, okay. So P complement का complement into Q plus P bar and Q bar. Fine. Okay. So this is the thing. Now what here we will get? We will get P Q plus P bar Q bar. This is the expanded form of what? This is the expanded form of XNOR gate. Okay. So it will become P XNOR Q. Okay. So it will finally become P XNOR Q. Okay. So this is the right hand side. So we have solved this question. Left hand side is equal to right hand side. Okay. I guess you might have understood it till now. Okay. So in XOR gate, we can keep one thing in mind. In XOR gate, if any of one of the input is complemented, then the whole function gets complemented. So here we can see that P XORed with Q complement, so whole function is complemented. Fine. Here P complement is present, so whole function is complemented. Here obviously means when both the things are complemented, so what happens? Double bar is present. It would result into P XORed Q only. Fine. So this is the basic thing which you can keep in mind, and this is the example that I have taken, and I have explained you that how you can prove that, how we have proved the left hand side is equal to right hand side. Fine. Now, so this was all about the basics of the logic gates, and I hope that आपको सारी चीजें समझ में आई होंगी about the basics of the logic gates. Okay. So I hope that you would have understood all the basics of the logic gates and the basic concepts of the logic gates. Fine. So in the next upcoming lectures, we would be taking the further topics. Okay. Thank you so much.